Alright, so we are reviewing for the Unit 5 test now, together like always. And then we'll have the unit test. And then remember, you're going to make sure you gather up afterwards all of your answers from your unit test, because that's where semester exams come from. Alright, so on this first one, it says 1 correctly found a table of values for each equation in a system of equations as shown below. What is the value of y in the solution? So remember, these are the easy ones when you have a table. Now, finding the answer in a table isn't always the easiest thing, but if they already give you the table, it is. What point do both tables have? So like here 0 is 9, but here 0 is 4, so that's not a solution. This one's 1 equals 7. There's not even a 1 here, right? Here 2 equals 5. Here 2 equals 5. So if I put in a 2, I get out of 5 either way, right? So it says what's the y? So what's the y in the points where they're the same? Or the point where they're the same? Well, the y is this column. What do we circle?
2 and 5.
Well, 2 and 5 is the point, but which one's the y? The 5. Yeah. They could have easily asked for the x. If they did, just make sure you know the difference. If they asked for the point, it's 2, 5. If they asked for the x, it's 2. If they asked for the y, it's 5. Okay, so just make sure you know the difference. On the table, even if they didn't put the x in the y, just remember x is always first. Okay. The next one says a system of equations is shown below, and it wants us to solve. So this is what we've been doing. We can do substitution on this one fairly easily because it's already solved for y here. But if you want to do elimination, you can rearrange the equation to do it. But like I said, it's already kind of solved here. If you look, y equals x plus 1. So if I go to plug it back into this one, here's 3x plus 2y equals 10. But instead of y, I'm going to put what y equals. So that would be the x plus 1. Remember, that's what substitution is where you substitute what something equals for the letter itself. Then we just got to solve here, but it does take a couple steps. We got to get rid of parentheses first. I'm going to leave that 3x here. What's 2 times x? No, x is just x. It's just 2x, yeah. Then we have 2 times 1, 2. And then we combine our like terms. If you look, there's an x here and here, but this number has to go on to the other side. So how do you move a positive to the other side? Make it negative, yeah. So that'll cancel. But what's 3x plus 2x? Plus. Yeah, 5. 5x. And then what's 10 minus 2? 8. And then what do we do? Not times. How do you get rid of the... It is 5 times x, but yeah, we divide to get rid of it. So I'm just going to leave that. You can, if you really want to, make it a decimal. It doesn't matter. So the x is 8 over 5. Then we take that and we plug it in here. So for the y, we've got 8 over 5 as our x plus 1. So 8 over 5 plus 1. Somebody put that in your calculator. No. 8 divided by 5 is going to give you, it's like 1 point something. Here, look. 8 divided by 5, it's 1.6. So if you wanted to put 1.6 here, it's fine. But it's the same thing here, but then we're going to add 1 to it. Say we're going to add 1. So we get 2.6. So if you put your answer in point form, x was 1.6, the y was 2.6. Or if you wanted it as a fraction, the x was 8/5 and the y was 13/5. I don't care which way you put it. It's up to you. Here's the thing. If you did put it in a decimal and then you look down and the answers are all in fractions, you can just put them in the calculator to see which one is the same decimal. So don't worry about which way it is. It's either way, your choice. Alright, so one of these, same thing. Alright, the next one says to graph the solution set. Olivia, because you were out yesterday, this is what you missed, so pay extra attention on this one and it'll also help you with the missing. So we have graphed inequalities a bunch of times before this. It's the only difference with a system is you're graphing both of them on the same graph. So I'm going to start with this one just because it's already y equals. Remember, you use like y equals mx plus b. You always start with b, and then this is your rise over run. So here we're going to start with -1. And then what number's in front of this x if you don't see a number? 1. So that means if I want to rise and run, I got to do 1. So I'm going to rise and run 1. So really it's just up and over 1 a whole bunch of times. Now, once I run out of room going up, I'm going to do it down and left because it keeps the line going. So this is the line that's used for this one. Now notice it has the equal line under it. That means it's a solid line, so we connect the dots. And is that greater than or less? This symbol. Greater than. So we would shade above. Okay, so that's this one. Now the other one, the x plus y is less than or equal to 5. We have to solve for y. But the good news is that one's not that hard to solve. You just have to move the x over. And how do you move a positive to the other side again?
I mean the y.
How do you move a positive?
Subtract it,
yeah. Yep. So the y is less than or equal to -x plus 5. So on this one, we're going to start here at the plus 5. So 1, 2, 3, 4, 5. And then it's still, there's understood to be a 1 here, like Olivia said on the last one. It's just this time it's a negative. So you're going to do the exact same thing, but you're going to be going downhill. So down over 1 over 1, down 1 over 1, and just keep doing that until you get your whole line. And this one, does it have the line under the inequality? Right here. It does, right? So after you have all of them, connect them. Now, is this a greater than or a less than?
Less than.
It's a less than. So on this one, we shade below. So remember, your answer is the area where both are shaded. So that's harder to see sometimes, so I'm just going to make it darker. This is the section that got shaded for both lines. So anything in here or on this part of the lines is the answer. Okay? Over here is just shaded by 1, and up here is just shaded by 1, and over here is not shaded at all. So this is the area that's the solution set. Alright, this one says the school band collected $2,892 for 480 tickets sold to their spring concert. Adult tickets were $8 each, and student tickets were $5 each. How many children's tickets were sold? I'm assuming children's is student. I don't know why they switched the words there. That was probably just an accident on my part. Because I typed this part, so I just wasn't paying attention. But if we're using adult, I can use A, and student or children, I can use either. I'm going to use children only for the simple fact that student is an S, and sometimes that looks like a 5.
Maybe there's something else there.
Huh?
I thought you meant something else.
No, I'm just saying children and student tickets are the same thing in this case, so I'm just using a C because it's easier to tell it's a letter. S's sometimes look like 5s when I'm writing them. So they collected this much money. Adult tickets were $8, so I'm going to put 8 with the A. Children's tickets were $5, so I'm going to put 5 with the children. And the amount of money they collected was this amount right here. That's one of our systems. The other system is not based on money, it's based on how many tickets. Well, we know that they sold $480 tickets. So however many adult tickets they sold plus however many children tickets they sold is $480. Okay? Now you can solve this with substitution or elimination. It doesn't really matter. If you're going to do substitution, I would solve this one because there's no letters or no numbers in front of the letters. If you're going to do elimination, it's also pretty quick because we can just make this one match this one. I typically do the smaller number if I'm going to do elimination. Try to make the 5s match. If I multiply this by 5, I have to multiply everything. And since this is a positive 5, I'm going to multiply by a negative. Remember, because that lets us combine easier. So I'm just going to rewrite them over here. The top one I'm leaving. Okay, negative 5 times A is negative 5A. Negative 5 times C is negative 5C. And y'all help me out. What's negative 5 times 480?
400 what? 180?
Negative 5 times 480.
440. 540. 5 times 8 is...
You can use a calculator. I know it's negative because a negative times a positive is negative. Let's see, go to 0. I think that's right. It is? Okay. So then we combine. 8 minus 5 is 3. The 5 minus 5 cancels. And then the 2892 minus 2400, that just leaves 492. Then we divide by the 3, just like we always do. So the adult tickets, the amount we sold, is we divide. Somebody verify.
490 is the other side.
That's right? Okay. I was trying to do it in my head, but y'all had the calculator, so I figured it'd be faster. So we plug that in here. The adult tickets is 164, plus the children's tickets is 480. We just subtract. This one's an easy one to finish solving. What's 480 minus 161? I mean 164. 480 minus 164.
It's going to be 324.
Did you subtract?
Yeah. Oh, you're doing these carrying.
Is that what you said? I can't
I said
remember.
324.
Oh, okay. So it says how many children's tickets were sold, so this is the one we needed to know. They could have just as easily asked how many adult tickets were sold. Had they asked that, we could have stopped at this part and not plugged it back in. Okay?
That's all that.
Yeah. This one is the same as the one right before that. You're graphing your solution set. You can't really graph it until it's y equals. Or in this case, there's an inequality, not an equals, but same kind of concept. So for the first one, you've got 2x is greater than y plus 2. You need to get y alone. So I can minus 2 to do that. But then just remember, we like to have y on the other side. So if I make y on this side, see how it's still pointing at the y? I still need to make it point at the y. If I switch sides, it flips this. But I have 2x minus 2 for this one here. On this one, it's in the right order. I just got to minus my 2x. Y'all remember how we always move over a term to the other side by changing its sign? So you got minus 5y is less than or equal to negative 2x plus 10. But we always have to divide by this number in front. And remember, when you do that step, anytime with an inequality that you multiply or divide by negative, it flips this. So this less than becomes a greater than. Negative divided by negative is positive. So 2 over 5, we just leave a fraction. And then 10 over negative 5, that's a positive divided by negative, that's negative. 10 over 5 is 2. So we just graph this one, and we graph this one. So 2x minus 2, start at minus 2. And then remember, your slope can be a fraction just by putting it over 1 if it's not already. That means we rise 2, run 1. Rise 2, run 1. I'm going to just do it over and over again until I'm out of room. And I'm even going to go the other way. If I go down 2 and left 1, I'm doing the same line.
Wait, rise 2, run 1?
Yeah. And this has the line under it, so I can connect these. And then also, it's a less than. So remember, that means we shade below it. So I'm shading lightly over here. Okay. For this one, I'm going to start at -2 as well, which is the same point. But this time, I'm rising and running 2 over and 5. So rise 2, but then I run 5. I rise 2 and I run 5. Or I can go down 2 and left 5. So this has a line under it, so I'm going to connect it as well. But that's a greater than. So for this one, I would shade above. So the area that they're shaded for both is this part right here. This part is what's shaded for both.
How many for the last one?
You rise 2, run 5.
Okay.
Or in this case, when I went down 2, left 5. Alright, so this one and the one a couple questions ago were both inequalities that we were graphing. The next one is graphing lines, but it's not the less than or the greater than. It's just straight up the equations. So all we're going to have is 2 lines instead of the shading on this next one. But the starting out is the same. You still have to have y equals to graph it. So when I look at this one, the -x plus y equals 2, how do I move the -x to the other side? We add it. Yep. So I've got y equals x plus 2. That's the first one we're going to graph. So plus 2. And then remember, Olivia told us earlier on a different problem, if it's just a letter, it's just a 1 in front of it, right? And if that's what needs to be a fraction, it's still a 1. So that just means I'm going up 1 and over 1. So we had this one on the one next to it. See how we had the graphing going up 1? The only difference is we're not going to shade here. So when you're graphing your line, that's just it, just the line. For this second equation, we got to solve it too. How do you move a 3x to the other side? It's being added. Yeah. How you tell the difference, and I know that can be confusing because sometimes when you have a number in front of the letter we divide, but then sometimes we add or subtract. We're trying to get y alone. So the x term is the one that gets added or subtracted based on what its sign was. If there was a number in front of the y, that's what would get divided. Just so y'all know, because I know that part can be different each time, and that gets confusing. Yeah. All right, so we start at 6 on this one. So here's 2, 4, 6. And this one, if I want to make it a fraction, I just put over 1. That's down 3 over 1, which is the same point that's right here, right? Down 3 over 1. I'm just going to keep doing it until I'm out of room. Which didn't take that long on this side. So the part where they meet's right here. It's kind of hard to tell there because my line's a little crooked. But the point is at 1, because it went over 1 and up 3. So it's at 1, 3. That's the solution. The point. But this is what the graph looks like. There's no shading on this one. Because there's no less thans or greater thans on this one. It's just equals.
Okay, well, how do you tell Sleeping Beauty to stop snoring?
Nudge him. Wyatt.
Can I push the syrup from her?
No, but just nudge him gently.
Oh!
Wyatt. Wake up, man. You're missing the review and your snoring is distracting your classmates.
School's important, Wyatt.
Lies.
Alright, we only have a few more. Alright, this one says the graph below shows the distance from Dallas of 2 cars over a 4-hour period. Car A is driving towards Dallas, and car B is driving away from Dallas, which is why car B is getting further. If you look at the distance, it's getting further, whereas car A is getting closer. Alright, It says, based on the graph, how long will it take for the two cars to be the same distance from Dallas? So same distance. That means where are they the same here? Well, here they're not the same. So if you're looking at where they're the same, it's going to be right here, right? Where they cross. But it says how long will it take for them to be the same distance. It didn't ask what the distance was, right? What the distance is, if you look, is 20 miles. But how long it takes is this way. So pay attention, because both of those would be valid answers to different questions. Okay, the solution is 220, right? But which one is how long it takes? Well, that's time in hours. So it's 2 hours. Okay? If it said after, let's see, how far apart would they be when they've been driving the same amount of time, then the answer would have been the 20. Okay? So pay attention to which one they're asking. The next one says Angola High School sold 3 times as many children's tickets as adult tickets for the school play. The total amount collected was $357.50. Children's tickets cost $2.50 and adult tickets cost $5.
Is this a review?
That's a 5. Yes. Our test is coming up.
Are we doing the whole thing?
Yeah. We always do the review together
Yeah.
so that you're adequately prepared for the test, right?
I still want to know
It says write the system. Does it say anything about solving the system? No. That means your answer here is going to be a set of equations. Okay? Let's go with the easy part. That's the money, because it straight up tells you children's tickets cost $2.50, so $2.50 per child. Adult tickets cost $5, so $5 per adult. And this is how much they made, $357.50. So this is the easier equation because it's about the money. Okay? They don't tell you how many tickets they sold, but what they do tell you is they sold 3 times as many children's tickets. Okay? So if I'm 3 times your age, do we multiply me or you by 3? Us. Y'all. So if I'm 3 times your age, you multiply you by 3. Well, it says... I'm going to cry that you asked if I was 4 times your age.
No, I said 2.
Oh, I thought you said 4 or 3. I'm between 2 and 3, to be honest. I'm more than double your age, but I'm not triple your age. To be 4 times your age, I would be in my 70s, and that's why I said I would cry if you thought I was 4 times your age. Not that there's anything wrong with being in your 70s, but I'm only 41. So that's why if you thought that I was 4 times your age, I would cry. Maybe not 70s, maybe late 60s, depending on, because you're not all the same exact age. So if it says we sold 3 times as many children's tickets, that means we multiply 3 times the adult, right? If I'm 3 times your age, you multiply you. So if we sold 3 times as many children's tickets, then we multiply adult by that. So the children's was 3 times the adults. That's your other one. Okay? This one kind of hit a little bit. When you first read the problem, it's not clear that there's 2 equations. The one equation's real obvious, but the other one kind of hides a little bit. But does this work? If we sold 3 times as many children's as adults? The common mistake here is people putting 3 per child equals adults. That would imply the adults was the bigger one. Okay? So we don't have to solve it. That's it on that one. Alright, looks like we only have 2 more questions, so we're almost done. This one says Brenda needs to solve a system of linear equations below for her homework assignment. Graph these 2 functions and estimate a reasonable solution to the system. So here's the thing. They did not put numbers already on this graph, and the reason is look how big those numbers are. If you notice, those 2 numbers are quite large of numbers, like small because they're negative, but you know what I mean, like the number itself is big. That means we can't do the counting by ones here, you know? So if I make my graph this way,
Are we talking about tens?
yeah, we probably could do, well, if we do tens, then that's a negative 70. I'd have to give myself more room. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Might even be better off being 20s. But I bet I can do 10s and make it work if I put my axis here. I'm guessing and checking this part as much as you would be. Okay, although you can put the graphs into the calculator, like Gary, you were showing me the other day. It's just that counting what you're counting by is the hardest part on this one. So here's at negative 70. So if we're counting by tens, the negative 70 is way down here because that was 7 lines down. But we're going up and over 9 over 1. That's almost 10, right? So if I'm counting by tens for both lines, to go up 90, I'd have to go over 10, wouldn't I? Do y'all see what I'm saying? If we're counting by tens, I can't just go up 9. So I made that a multiple. If I go up 9, instead of 9, go up 90, then that's not over 1, it's over 10. So I'll go up 9 and over 10, which is just 1, isn't it? So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1. So this is a really steep line. And I've guessed just like you would be the first time you're doing it to see if we even cross on this graph. Okay. The 32, here's 1, 2, 3. So 32 would just be past that. And that's a 2. So if I want to go by tens, 20 over 10, right? So that would be like 1, 2 over 10. That's like here. So if you look, they cross right around in here. And that's at about, and this is an estimate, for the x, that's about 5. Because remember, we're counting by tens, so it's halfway. And then here's negative 10, negative 20. This is my estimate. I'm not saying that's the exact answer. It's an estimate. It's the closest guess I can make between those two. Okay? Alright, last one. It says Mike bought 7 items for lunch that cost a total of $16. Hot dogs cost $1.10 and cookies cost 75 cents. Write a system of equations. Again, doesn't say anything about solving it. Okay? So what are our 2 items that we're talking about here? So what letters do we want to use for hot dogs and cookies? H and C. So he bought 7 items, right? So however many hot dogs he bought and however many cookies he bought, together those numbers are 7 because he bought 7 things. Okay? And if you look, hot dogs cost $1.10. So $1.10 for hot dogs. And cookies cost 75 cents. So 75 cents for cookies. And he spent how much money? 16. So there's our system. Okay? You don't have to actually solve this one. Okay? That was our last one on the review. Remember, your questions aren't necessarily identical, so don't just automatically pick the answer you had on your review. Do the process.
Wait,
okay?
do I give this to you?
No, I want you to, unless you want me to hold it for tomorrow.
Yeah,
I don't mind doing that. But, like, it's yours.